All right, so just a quick little agenda for everyone on what we want to go ahead and cover in today's session. We're going to first talk about datums and specifically try to define what a datum is for everyone so that they understand the importance of datums when using GNSS equipment. We'll note some of the common datums that are out there that are being used today, and then we'll relate those datums with the Trimble software. And one of the things that we're going to speak at length about today is how to use the datums that are available to us today within the Trimble software and address some of the global and local positions based on the datum that you choose in your Trimble software and workflow and how that needs to be used properly in the field. Then we'll touch on geoid models, and within our geoid models we're going to discuss Geoid 12A and Geoid model interpolation. Some of you may know what that is, some of you may have no idea what that is, so we're going to cover that from top to bottom because that has also been introduced into the Trimble software as of late. And then we will discuss geoid and datum relationships as they relate to each other and give you some recommendations that we've received from some of the NGS personnel in regards to how the geoids, specifically Geoid 12A and Geoid 2009, relate to the different datums that are out there or realizations within NAD83. We'll finish up today's session with talking about the Opus solution reports and review those and look at how to use those properly within the Trimble software, as well as the NGS data sheets that are available and that people use every day with the Trimble software as well. With that in mind, one of the things that I always like to do is have some objectives that we want to cover in this class or this session today. I've got 4 objectives up here today, and we'll define those for you just briefly, and this is what I want everyone that attends today's session to get out of today's session. Certainly want everyone to understand the proper use of the NAD83 2011 datum when using the Trimble software solutions. There's been a lot of questions on how that's being used and how that should be used, and we want to make sure that everybody understands that once they leave today's session. That's very important. We also want to make sure everybody understands the difference between a local and a global position within the Trimble software. If you remember back in the days when we used to train, say 10-15 years ago, a lot of times we would say that WGS84 and NAD83 were basically the same position. Out to the 7th decimal place, they're pretty much the same. You wouldn't really see a difference. Well, that has changed over the years, and so we need to make sure that we understand within the Trimble software that there's a local GNSS position and there's also a global position, and they are treated differently in a lot of the newer datums that are being used today. The third objective that we want to cover today is determining what geoid model is suggested to be used with what horizontal adjustment. A lot of questions that we get are, hey, can I use Geoid 12A out in the field with every project? All right, and that's not necessarily the case. You don't always want to use the latest and greatest geoid model with every project, so we'll kind of cover that a little bit based on some suggestions that we've heard. And then the last objective for the day is to properly use the Opus and NGS data sheet with Trimble software. We see a lot of people using Opus solutions and NGS data sheets, but maybe not necessarily in the right manner with Trimble software solutions. And there's also some shortcuts that we'll show you when using those particular solutions. Okay, so what is a datum? So if you look at this slide, and I got this from our NGS advisor here, it's a very nice little representation of trying to get an idea of what the datum really does for us when we use our GNSS equipment. You can see a definition there at the bottom, but essentially if you look at the blueprint on the left and look at the concrete foundation of that particular structure, the datum is pretty much the same thing when it comes to mapping. It is our foundation for the mapping that we do, and it's very, very important that the datum exists. And so you can see that based on the representation here and the definition at the bottom, we're basically defining the datum as a foundation or a starting point for our geospatial data points. And as you can see here, there are a number of different datums that we trip across, run across, that our clients use, that are requested to be used in the field and to try to get into existing data and maps and things of that sort. You can see some horizontal datums and adjustments here all the way down to NAD83 up to the North American datum of 2011, as well as some vertical datums 27 and 88 there, and then within NAD83 itself you have different adjustments and realizations that exist all the way from 86, 96, NSR is 2007, and then the latest, which is the 2011 realization of NAD83. So the question becomes, where does my datum fit in, and why is it such a big deal now? It never really was before. We didn't talk about it that much. So if you look at it over time, you've noticed that our datums have really evolved from 2D and say 1D geodetic datums like NAD83 86 adjustment or like NAVD88 to geometric 3D and even 4D type of datums that exist today. So you see, by adding ellipsoid height or adding velocity to the datum, because we've gotten so accurate and pinpoint with a lot of our reference stations that NGS has noticed some movement and things like that, so we've added other things within the datum to make it more precise, and that it becomes something that we need to take into account when using our GNSS equipment. So you notice here, as the datums and the projections or the datums within the projections have evolved, that that different attributes have been added to those datums to make them more precise. So looking at the coordinate systems that we use, state plane, some of us using county coordinates, which we'll also discuss in today's session, or local site calibrations. When working with the GPS equipment, we're working on the WGS84 coordinate system. The system has to create some kind of localized datum to work in the project area that you choose to work in. Whether it's state plane, you have a specific state plane state and zone typically, or if you're using a county coordinate, you have a specific county that you're working in, or a local site calibration, which is localized to the area. We need to localize that ellipsoid, and that's done with this datum transformation. And usually it's a published value, and it usually is either a 3-parameter or a 7-parameter, which is supported by the Trimble software, or even up to a 14-parameter, which NGS uses with the latest 2011 datum. So this poses a question about WGS84 and how it's changed and what its relationship with NAD83 is, and we need to make sure that everybody notes today that as it exists today, WGS84 and NAD83 are not the same. Autonomous positioning of GPS on the WGS84 ellipsoid is not the same as it was 10 years ago, and so we cannot make that same relationship. And so it's important to understand that these two do not equal each other. And I put a little map up here that NGS has provided just to show some slight adjustments, just even from 2007 to the 2011 NAD83 transformation. And you can see that there are some pretty large differences in some areas, up to 20 centimeters, and even more. But in most of the central U.S., the states that are attending today's webinar, you'll see they're anywhere from 4 centimeters down to a centimeter or 2. But there is a difference. One of the things when I first started training GPS, we really wanted to make sure everybody understood is that GPS has enough error in itself that it's important as a user to not induce more error into the GPS by doing some things improperly, whether it's selecting the wrong datum, typing in a coordinate and you've chosen the 2011 datum, but the coordinate actually is a 96 adjusted value, all you're doing is you're adding error to your position. And one of the things in GPS that we are always trying to do is to minimize that error, and that's the purpose of today's session when it comes to the coordinate systems and the transformations that exist. So in the next few slides, I guess what we want to do is just point out a few things in the Trimble software and what the parameters are for the different types of datum transformations that exist for state plane and county coordinates, which we deal with every day. So in this particular slide, you can see that we're demonstrating the state plane coordinate system NAD83 CONUS, which is a Molendesky datum transformation, that the parameters are basically zero. There is basically no difference between the WGS84 and local ellipsoids that exist within that particular datum transformation. And this is what we would say in the past, where WGS84 and NAD83 are virtually the same. Well, that isn't necessarily true anymore. And then NGS published the Cores 96, a 7-parameter transformation, and you can see that now from the WGS84 ellipsoid that we described to the local ellipsoid, there are some transformation parameters, and those numbers there that you see on the screen in translation X, Y, and Z are in meters. So there's a pretty significant difference just in Cores 96. You know, translation-wise, a negative 1.9 meters. So there's quite a difference than what we had on the previous CONUS datum. Then just recently was introduced into the Trimble software the NAD83 2011 transformation, which is truly a 14-parameter transformation, but the Trimble software doesn't support all those parameters. They support a 7-parameter maximum transformation, so that's what they're using. And you can see that those values here, if you watch briefly on the translation XYZ and the rotation XYZ factors, that they're very close to Cores 96, but they are different. And that transformation occurred within the Trimble software in Trimble Business Center at version 2.81. So if you have version 2.81 or higher of TBC, you will see that you have a selection now of NAD83 2011 as a coordinate system group within the software. Also within Access, the Access version 2012.10. So if you're running Access version 2012.10 or newer, you will also see now when you choose state plane a coordinate system group called NAD83 2011. And this is the naming convention that's used within the Trimble software right here. And I've also noted it right here. NGS typically notes it as NA 2011, but for purposes of today's discussion, we're going to assume that these two are the same. It's just a naming convention that's different. Okay. And then lastly, we have these Minnesota County coordinate systems and also Wisconsin County coordinate systems that are basically really not translated, but basically the ellipsoid is puffed up with a scale factor. So the ellipsoid exists at the mean elevation of that particular county, which makes this a slightly different animal to deal with. You notice that the parameters for these transformations are 2 WGS84, and these state plane transformations are from WGS84. So if I back up, these state plane coordinate systems are true grid-based coordinate systems, and you got to use some kind of combined ground scale factor to get to ground. Where in the county coordinate systems that exist within Minnesota, that's already done for you with this this scale factor by puffing up the ellipsoid to the mean elevation of the ground. So these are already ground-based systems. So that creates a couple of notes that we will note here today, just to make sure that you're using this coordinate system properly when you're using county coordinates. So here's that notation. When you're using the Minnesota County coordinate systems, there are two settings that are very, very critical because of how the ellipsoid has been transformed in this coordinate system. Again, this only applies to using the county coordinate systems and not state plane. So do not get those confused, please. Under your COGO settings within your Trimble software, your distances should be set to grid when using this coordinate system, not ground like you would with others. And there's also a setting there called sea level correction, and that sea level correction always needs to be unchecked when you're combining GPS and conventional total station data within a county coordinate system. It's very critical that that is done. And again, this can be found under the COGO settings in Trimble Access. And in there, under distances, you need to set that to grid. Your sea level correction needs to be unchecked, as you see in this view here. So that brings us to one of the major topics of today's discussion, and that is global and local coordinates within the Trimble software. So as we've noted, as things have evolved over the last few years, that the datum transformation is becoming very key, very critical within our software. As an example, when using the NAD83 CONUS datum transformation selection, the transformations are usually set, or basically the transformation parameters are set at 0. You cannot change that. So in all essence, the global and local coordinates within the Trimble software are going to be the same. So when you go and key in a WGS84 value for starting your base station, as an example, the local value for that same position will be the same as the global value in the Trimble software. However, once you select a different coordinate system transformation like you do with these examples in the second bullet here, these 7-parameter transformations like NAD83 Cores 96 or NAD83 2011 or even the county coordinate systems, since there is a transformation, as you guys just saw within the slides that we just presented, the global and local coordinates are now different. So that brings an interesting point to what's been happening to users in the field. For example, if I go out in the field and I set up my job with a state plane coordinate system, and I choose the NAD83 2011 coordinate system group within the Trimble software, and I key in a WGS84 latitude, longitude, and height for my, say, my base starting position, that's going to give me a position on the local value that is much different than my global value because of that transformation. And what I will see is I will see a pretty major error in the field because that is not the correct value being entered in the field. And we'll correct that today. So this becomes a very important position when setting up our survey or starting our base. What do I enter? What needs to be put into my starting position? Is it a grid position? Is it WGS84? Is it local? Does it matter? Those things need to be understood. Otherwise, you're going to see some errors in the field. So this global local coordinate value becomes very important when we're using these newer datum transformations. The same thing happens in the office, and this is where we're seeing it a lot. For example, if I choose a state plane project and use NAD83 CONUS as my datum, and I get an Opus solution back, and I want to update all my side shots from my Opus solution, typically we see users go into TBC, they edit the global position, recompute, and everything is fine. But lately a lot of people are seeing, as you know it, on your Opus solutions coming back as NAD83 2011. They pick that coordinate system group, do the same process, go into TBC, and edit the global position, and everything is off by 3 feet. And that's what's going to happen because the transformation is being applied. In essence, you're editing the wrong position. You need to be editing the local position in that particular case. So it's very important when setting up TBC, and we'll show you some examples of that here in just a moment. So you should be paying attention to what's being used within the coordinate system. and also what's being used within the NGS Data Sheet or the Opus solution that you're getting back from NGS. Because in a lot of cases, those are 2011 values. So let's look at some examples when using state plane coordinates and then maybe some of the different datums. So for this first example that we're going to talk about in Trimble Business Center, what we're going to do is we're going to show you an example of the difference between the local and the global position when using different datums. And what I'm going to do is I'm going to change the presenter here for just a moment. And I'm going to hand this over to Brian Baker, who's one of our panelists, and he's going to give you a little demonstration on how this difference is being applied and how you see it. All right, Brian, that's you're up.
Thanks,
and I
Steve.
can see your screen just fine, so TBC is up and running.
Okay, terrific. Welcome everyone to our session today, and I'm going to, as Steve said, give you a demonstration of what happens when you are actually selecting the datums and the coordinate systems, and we'll see the actual things that Steve was talking about, and maybe that'll solidify it a little bit more in your mind. This is a tough subject to get your brain wrapped around for a lot of people, even us from time to time when we get thrown different scenarios. So this is Trimble Business Center 3.0, and it's the latest version. And what I'm going to do here is I'm just going to go into my project properties. I created just a blank project, and it doesn't have any coordinate system set. And if I go to coordinate system, you'll see that it's just a default. And I'm going to go to change my coordinate system. And so I'm going to select coordinate system and zone. And you'll notice that this dialog box in TBC 3.0 is a little bit different than it was in version 2.81 and earlier, where it was the old Trimble Geomatics Office type dialog box. So I'm going to select coordinate system and zone. The first thing that I'm going to show you is a little bit of difference between state plane coordinates and the UTM coordinate system. And when you pick the UTM coordinate system and you pick the zone, and for example I am in 13 north, and if I say next, I actually have the opportunity to select the datum that I want to use. Because UTM is a worldwide coordinate system, the datum that you select is a function of the part of the world that you're working in. So you'll see that there are a lot of different datums for all over the world, including, if I go up here, NAD83 2011. You can see the different datums here, and this is worth noting right here, NAD83 PA11, that's the Pacific plate. So if you're over in California, you need to use the Pacific plate, but if you are in the rest of the continental U.S., particularly within our footprint and east, you'll use the NAD83 2011 datum. So we would pick this. Now, a lot of people don't use UTM. They use state plane coordinates. So if I go back and change to state plane, you'll see that I have U.S. state plane 27 and 83. These two have been a part of Trimble Business Center and Trimble Geomatics Office since day one. Now, with version 2.81 and greater, we have U.S. state plane 83 parentheses 2011. Notice that when I pick any of these, and the first thing I'm going to pick is just NAD83, it asks me for the zone, similar to the way that it did in UTM, except the difference is that it does not ask me for a datum. And that's because in Trimble Business Center, when you select state plane, the datum is predefined. And this is why we really haven't had to deal with that much, with datums as an issue that much, because Trimble had pre-selected the datum for us. And in the case of NAD83, the datum, or excuse me, in the case of state plane coordinates, NAD83, the datum was NAD83, which was essentially the same as WGS84. So I just pick NAD83, and I'm going to pick the Geoid Model, Geoid 09, CONUS, and I'm just going to hit Finish here. And then what I'm going to do is just create a point so you can see what happens. So if I go to CAD, create a point, and I put in a global value of north 40 by west 105, something very simple, and an elevation of 5,000 feet, and hit Add. Oh, need to change this to global. I thought I did. There we go. Once I add that point, you should be able to see that point on your screen. And I'm going to highlight that point. And then we're going to take a look at its properties. And you'll see over here on the right that the global value and the local value are identical. Even though I keyed in a global value, my local value is exactly the same because we selected NAD83 and there is no transformation, or it's just a 3-parameter transformation. And then that gets us to a grid coordinate of this value. Now, watch what happens when I go in. I'm going to leave the point the same, but I'm going to change my coordinate system to NA 2011. So coordinate system and zone, NA 2011, Colorado North. Next. And again, our datum is part of our coordinate system group that we're selecting. And this time I'm going to use Geoid 12A. That is the Geoid model that goes with NA 2011, and hit Finish. And you'll see on the right-hand side of the screen the properties change. So now you'll notice that the global value and the local value are significantly different, and they are different in excess of a meter. So we are seeing instead of an incremental change in the global and local values, we're seeing a fairly significant change because we went just from a 3-parameter transformation all the way to the 7-parameter transformation that is in NA 2011. And where people are getting twisted up is that all of the data sheets and all the Opus solutions that are coming in from NGS are giving you values as NA 2011, which are the local coordinate values. Yet people are putting them in as global values. And when you put a local value in as a global value in the NA 2011 coordinate system, it will transform it yet again, essentially giving you a double transformation of that value and causing you to be off, as we'll see in some results, by more than a meter. So that's hopefully a very illustrative example of what we've been talking about up to this point. And so with that, I will turn it back over to Steve and let him continue on.
Okay, that was a good illustration of that global local difference that we described in the earlier slides, right in the Trimble software. So what we're going to do is we're going to do the same thing as we just did, and hopefully my screen pops up here with Trimble Access. But this time we're going to use the Trimble Access software to show you the same thing that Brian just showed you, so that you can see that it's consistent, and you can see that the error exists when going between the two. So we need to make sure that we do this properly. Okay, so I'm just going to set a job. Set up a job, and I'm going to select a coordinate system much like Brian did, right? We select our coordinate system from the library. And again, just like Brian had showed, we have several choices here. In Trimble Access 2012.1, they introduced this new selection group, which is US Date Plane 2011. There's a couple of things that Brian had mentioned that I want to show you as well. So when we pick US Date Plane NAD83, notice we cannot change the datum. It is fixed. It is already set for us. All we can do is change the zone. Trimble Access does remind you what that datum is, but it cannot be chosen or changed or modified. Okay, so I'm going to choose the same coordinate system zone and do the same test that Brian did. But we're going to do this on Trimble Access to show you what's going on. I choose a Geoid model. In this case, I'm just going to use Geoid 12A just because it's convenient for me at this point. Hit Store. We'll talk about those Geoid models in just a moment. Accept that job, and then what I'm going to do is I'm going to key in a point here, right? And this time I'm going to key that in just like Brian did as a WGS84. Now the terminology is slightly different here. Trimble Access uses WGS84. Trimble Business Center says global. So for the sake of representation of terminology, WGS84 and Trimble Access and global and Trimble Business Center are going to be the same here. So I'm going to hit WGS84, which a lot of us do, and we're going to type in that same 40. What is it, 40? Sorry. And west 105 and 5,000. And notice I get a computed grid coordinate. What I'd like to do here is I'm just going to take a screen snap of that. And I'm going to throw that in Word here for just a moment so that we can review those coordinates. There we go. So that's our NAD83 CONUS position computed grid coordinate for this global latitude longitude value within the Trimble Access software. Okay. And I'm going to go ahead and store that. And what I'm going to do is I'm just going to recall that point number in this screen. It's just easier. And I'm going to demonstrate what Brian did and change it to local, and you'll see that nothing has changed. So this grid value and this global value, if I can kind of make them close, maybe not. We'll at least be able to look at the easting, right? The value is precisely the same here. All right, so that's what we want to see. So now when I go ahead, I'm not going to store that second time. I'm going to go into my properties of my job, and I'm going to do what Brian had just done to demonstrate the difference here. And I'm going to go to the Estate Plane 2011 system, choose the same zone. Go back into key in, recall my point number. I just like using this screen because it shows you both. And notice I am on local. Notice that my local position has changed much like it did with Brian. And because of that, something else has changed, and that would be my grid value. Notice that it's changed several feet in the easting, several feet in the northing, and several feet in the elevation, just because of this modification. It's very, very important to note. However, if I go back to my WGS84 position, it is correct. And that's what's happening here. That transformation is changing your grid values in your local, or I should say your local value, which in essence writes out your grid values for your computed positions with GNSS. So it's very important to set this up properly in the first place. Okay, so now if I go in here and type in a new point number, and I type this in local this time, right? Type in 40, oops, north 40, north 40, by west 105, and 5,000, right? And again, I'm keying this in local, like I should be, because I'm using the 2011 datum transformation. Notice then my coordinates match what they should have matched when I keyed it in with the CONUS transformation. So that should be a good test to show you what's going on with the difference between those local values and those global values within the Trimble software, both in Trimble Access and in Trimble Business Center. Now I know we have some questions, and we're going to try to keep those queued up and ask those towards the end. Remember, we just expected a ton of questions on this. So we're going to try to do this diligently so that we don't waste everybody's time, and we put on a good session. But if there are some questions that we don't get to at the end, we're definitely going to write out FAQs. So everybody who's registered here, make sure you put your question in the chat window. We will get every question answered one way or another, whether it's live or whether it's as a follow-up FAQ to everyone. So keep putting your questions in the chat window. The other panelists within today's presentation are monitoring those and making note of them, and they're also being recorded, so we can go ahead and review those at any time. And also the asker is also there, so that if there is a question about the question, we can ask the appropriate person who asked it. Okay, so that was a little bit on datums, and we're going to get into this just a little bit again and show you a couple of other real-world examples. But the next part of today's session that we want to discuss is the Geoid model. And as most of you know and have been using Geoid models with your GNSS equipment, it is basically a gridded surface that approximates the geoid, or mean sea level, for a surface area. These are the popular models, 12A being the latest. And essentially, if you think about a geoid model, it's basically just an interpolated difference between mean sea level and the ellipsoid. And that ellipsoid, as we just described, can exist in two locations, right? It's not anymore just to the WGS84 ellipsoid, as you see in this snapshot. It's not always just to this ellipsoid. It can be interpolated to the local ellipsoid as well as the global ellipsoid, and in some situations it needs to be interpolated properly. So that's one of the discussions that we wanted to have this morning. This was introduced by Trimble here recently, but as you note here in this particular slide, Geoid models are now being applied with respect to the interpolation method set within that file. So that allows us to enable either a WGS84 interpolation or local ellipsoid interpolation based on the Geoid model that we support. So we've got some information on what interpolation method you want. Traditionally, the NGS models that are produced are interpolated to the local ellipsoid, which is correct, and that's supported by the Trimble software. But there are certain instances that we need to interpolate those ellipsoids, or excuse me, those geoid models to the WGS84 ellipsoid, which you will see here in just a moment. So one of the questions that we get a lot is, when did this change occur? Do I need to be aware of this? Do I even care? If you are using Trimble Business Center 2.5 or higher, that interpolation occurred within the software at that version. In Trimble Access 2011.0 and higher, that geoid interpolation occurred there. So some of you may have seen on your data collector some message regarding interpolation, and it wants you to acknowledge that you understand what interpolation is all about. There are some Trimble documents available for this as well. We can provide those after the session. Just make sure and send, we'll have some contact info here at the end. Send us an email, and we'll certainly reply to you with a little bit more reading material on this. So the files that need to be interpolated to WGS84 are traditionally the county coordinate systems, because again, they're going to the WGS84 ellipsoid with their local ellipsoid parameters. So the WGS84 interpolation is required. Trimble provides a cutout of those when you update your coordinate system manager software within these versions of software. They provide those models in both Geoid 09 and Geoid 12A, and they are marked as MN for Minnesota and WI for Wisconsin. If you need to interpolate your own Geoid model, or if you want to create a cutout that includes a larger area for some reason, you can do that. Trimble has built a Geoid model configuration utility. You can go ahead and download that at this website, fpisurvey.com. Just select the Trimble banner and select Geoid Model Downloads, and it'll take you right to the interpolation location where you can download this little utility. And all this little utility does is it allows you to view the interpolation method of an existing Geoid model and change it if desired. And that's all it allows you to do. It's a very simple little routine. You can even do it to your Geoid models in Trimble Business Center, or if you have your controller connected, you can even route the software to view the Geoid model right on your controller and re-interpolate it. When you re-interpolate a Geoid model, you need to make sure that it's not being used by your software, however. So make sure when you're running this utility that Trimble Access is closed down on your controller, and or Trimble Business Center is closed down, so that doesn't give you a warning message that the Geoid model is being used and it won't let you interpolate it. One other note, just note that we also, Frontier has a little enhancement document on this, on how this configuration model is being used and why it's being used. So again, if you need that, make sure you reach out to your appropriate person, and again, we'll have contact info at the end of today's session to get that information. This is a little chart we made up, basically 4-column chart on recommendations that we have for using the Geoid model selection based on the datum of choice and what interpolation method those Geoid models should be and already are typically. So for instance, you can see the first 3 coordinate system selections that we have here on the left are U.S. state plane. So in the example of U.S. state plane using the CONUS datum, we're recommending Geoid 2003. If you're using NAD83 CONUS and the 2007 adjustment for your control, we recommend using Geoid 2009. If you are using NAD83 2011 as your datum within the state plane coordinate system, we recommend you use Geoid 12A. And that's how those Geoid models are developed by NGS relative to the coordinate system and its adjustment. 2003 being a localized Geoid model adjustment, typically to within the state boundaries, and the newer models 09 and 12A being more of a nationwide adjustment relative to how 2007 was adjusted, and as well as 2011. All of those Geoid models are localized interpolation, and they are built that way and they are delivered that way, so there's really no Geoid model interpolation that needs to take place if you're using those particular coordinate systems. However, when you're using county coordinates, that's a different story. Those county coordinate systems within the Trimble software that we described need to be interpolated to WGS84. That is a requirement. If they are not, you're going to see some fairly large discrepancies in elevation in the field if they are interpolated locally. So if you are running the latest versions of Trimble software, whether it's Trimble Business Center or Trimble Access, we need to make sure that your Geoid models are interpolated to WGS84. And then the datum, if you're using 86 or 96 adjustment, we recommend you use the 2003 Geoid model. And just like state plane, 07 matches up well with 2009 Geoid, and 2011 matches up best with the Geoid 12A.
Hey, Steve.
Yes, sir.
you mind if I jump in for a second?
No, go right ahead.
On the local interpolations, most people don't realize what a geoid model actually is, and it's simply a file of separation values on a grid. And this file of separation values, it's just whatever the NGS grids it out to be, but it's nothing but a huge list of separation values that begin at a starting point. Now, starting point is the latitude and longitude. The latitude and longitude is either locally interpolated or globally, WGS84 interpolated. So when the geoid model, the way that the geoid model is interpolated, either locally or WGS84, determines what separation value is being used for your elevation derivation in your grid value. So the reason that people are seeing problems with elevations usually results from a mismatch in the type of interpolation that the geoid model is using and the coordinate system that they're using it with. So as you can see from Steve's chart, the NA2011 datum uses the Geoid Model 12A with a local interpolation. And then at the counting coordinate system, Geoid 12A is used with a WGS84 interpolation. So that's basically the difference between the Geoid model interpolation is just the starting value that the Geoid model begins at for all the grid values, or all the separation values that are in that Geoid model. So just some additional commentary I wanted to throw in on top of that.
Excellent. Thanks, Brian. So you can kind of use this chart. This will help you understand, or at least give you some recommendations on, hey, what coordinate system I'm using, what geoid model should I use, do I need to worry about interpolation, that kind of thing. So in essence, one of the questions that we get a lot are, do I need more than one geoid model on my controller? Absolutely. Absolutely. And they need to be managed properly, just not forgotten. They need to be understood. Okay, let's move on to looking at and reviewing the Opus solution reports as well as the NGS data sheets. This is a standard Opus solution that you'll get. Most of you that use Opus are very familiar with this. It reports back some header information, some positional information, which we're interested in the NAD83 position typically, but it also gives you an IGS08 position. It reports out the UTM and state plane coordinates based on its choosing relative to the geographic location or your choosing. One of the things that we want to make note of is this important? If this NAD83 in brackets, parentheses 2011, a big deal, okay? Do I need to go in and set my coordinate system to NAD83 2011? Can I just use CONUS like I always do? Those types of things. And when I do that, is the geoid model a big deal? Notice that the ortho height is being computed back to you at Geoid 12A. If you're not using Geoid 12A, then you're going to enter in the ellipsoid height and choose the appropriate geoid model relative to what you enter in here to give you the computed ortho height. But if you're going to key in this position is NAD83 2011 datum when using Opus. So there are several ways to get an Opus solution into the Trimble software, especially important for Trimble Business Center. A couple of things that Trimble has done, which are very, very, what I would call handy, is NGS has provided an XML file output for your Opus solution. You can choose that if you use the Trimble Business Center software using their tool to send out your data file for an Opus solution, or you can also choose it on the NGS website as an output reply back from them. And what they will do is they'll send you this report, and then they'll send you a file that is a .xml file that has all that information as well. The nice part about the XML file is that file can be directly imported into the Trimble Business Center software, and no coordinate editing is required. It brings it in properly, it puts it in the right location, and it treats the value properly as either a local or global value relative to the datum choice that you've chosen. So the second option to bring in Opus solution is to edit the position manually. So you can go ahead and open up the point properties just like Brian had done in TBC before and type in the real coordinates. However, you need to make a note here to yourself that if your project is set up for state plane NAD83 2011, as Brian demonstrated in Trimble Business Center, you're editing either the grid value or the local value. You are not editing the global value. And you can see here, if I'm using state plane with NAD83 2011 Opus solution, I edit the grid or local position in TBC. That allows me to check other North American 2011 positions using either NGS data sheets or by measuring them. However, if I'm using state plane NAD83, the standard NAD83 selection within Trimble Business Center, and I've selected to use Opus, and I want to update my project, you have one of two choices. You either change the datum in TBC to NAD83 2011, then edit your local value, or grid value for that matter, or you leave it at CONUS and expect to get some slight errors, because there will be some slight errors relative to that position and the NAD83 CONUS datum. But it's very key that if you've set your project up, collected a bunch of data, get an Opus solution back, and that project was set up as state plane NAD83 CONUS and not NAD83 2011, that you are recommended to change the datum first to NAD83 2011 before you edit the position. So this is a question we get all the time. Well, what if I'm not using NAD83 2011 when I'm working with Opus? You know, a project requires something different. Then you are going to expect some small errors as you increase away from travel from your Opus solution. So say from my Opus solution, I edit, I'm traveling 5 miles away, you're going to get a small error because you have not chosen the correct datum and you've edited that position relative to the 2011 datum, because that's the solution you get back from NGS, right? We looked at that. That's what you're going to get back. Okay, so you will see some slight errors, and that error is definitely going to be compounded if you're working at higher elevations. So it is recommended to use the correct datum to minimize that error, again, like I discussed before. One of the key things that we're trying to do with GNSS equipment is minimize the error. And by selecting the wrong datum and editing improperly, you're going to just induce error into your survey. So we always recommend to select NAD83 2011 when setting up your project when you're working with Opus and state plane. And make sure you key in those positions as grid or local when using that datum. Same thing with an NGS Data Sheet. This is a traditional NGS Data Sheet version 8.1, so the newer version. You can see this designation was Point Apollo, and that'll come into play here in just a moment when we look at some of the field verification that we've done. Notice that in here we have a NAD83 2011 position. Now, not all NGS data sheets are going to say that. Some will not. Some will have a different designation. Always look for the adjustment year in parentheses there. In this case, it's 2011. So we would need to set up our project accordingly, right? Just like we talked about with Opus, we can save that data sheet in an HTML format. We can import that data sheet into TBC, into our project. Note that with the change of this data sheet to version 8.1, that version of data sheet is only supported in Trimble Business Center 2.6 or higher. So TBC 2.6 or higher supports that newer data sheet. Make sure you match your datum from the data sheet to the datum of choice within your state plane project that you're working with. And note that not all data sheets will be reported out in 2011. Make sure you review that. Okay, so let's just look at a couple of workflow examples here. So what I've got here is, well, first of all, let's look at the NGS Data Sheet. A lot of people don't know how to just save this as an HTML file, so I just want to review that first. So this is that same data sheet, Apollo, that we just looked at. Again, this is designation for 2011. It's as simple as going up here and clicking on a file and save as. This happens to be Internet Explorer. Same would be done with Firefox or Chrome or something like that. And now I can save the data sheet. I'm going to put it under this folder, and I'm going to call it Apollo Mission to Mars. We'll call it Apollo 2. I've already done this, and it's in HTML format, and we hit save, and that's it. It's done. Now when I go into my TBC project, now note I have two projects just to show you what happens here. I have one with NAD83 CONUS as my coordinate system designation, and I have one with NAD83 2011 as my coordinate system and datum designation. So there's my Apollo point that I shot with RTK. Again, I'm not in the right datum or coordinate system, and I can confirm that here under the project settings, and this is exactly what Brian had done. If I review my coordinate system, notice I'm at, this happens to be in Minnesota, so I am in NAD83 CONUS. I'm using Geoid 12A, and I'm going to go ahead and import that file. And what I'm going to do is import the data sheet first. I also did an Opus solution for this point too, so I'll show you how to import that as well. But we'll do the data sheet first, so there's less confusion. And I'm sorry, when we're using the software, there's a bit of a lag between what I do maybe and what you see. So I apologize if I go too fast here, but there's just a little delay. So the first thing is we're going to bring in this Apollo file here, this HTML file. Let's try that again. So you'll see that the smart thing about the Trimble Business software, Business Center software, is it reads each file and determines what it is. So it knows that Apollo is an NGS data sheet. I'll go ahead and either drag it into Workspace or just hit import. And it re-centers my project, but I'm going to go ahead and zoom in on this point. Again, I shot it with RTK here. And notice I'm off a little bit. I can go ahead and just review what that difference is. But what I would ask if you guys weren't unmuted, but what might you expect that difference to be? I bet it's going to be about 1 meter. I heard somebody say that. Sorry, pick the vector. Excuse me, it's not going to be 1 meter because I'm in CONUS, right? It's going to be off just a little bit, right? It's going to be off just a little bit because I'm using a CONUS NAD83 and I'm using 2011 for my data sheet. So it's going to adjust back down to CONUS and be a very slight error, okay? Relative to my RTK position, which was measured in CONUS. I do want to point out one thing for the data sheet here. Notice that the local value and the global value are exactly the same. And as we've demonstrated here today, that is not ideal, right? Notice that my position here on the data sheet matches my position in both local and global. We know that that's not true. That shouldn't be the case, okay? So we've got a little bit of an issue here that we need to deal with, and that is the wrong datum. So what I'm going to do is I'm going to go over to this other project, which is Estate Plane 2011, same RTK information. And this is what we see a lot of people have a problem with. Again, I'm using NAD83 2011, Geoid 12A. I'm going to do the same process. I'm going to go and import that data sheet. Again, like I said, there's a slight delay, so I apologize if it feels like I'm going a little slow here. I'll go ahead and zoom in on this point here and again observe the difference between my RTK observation and my my Apollo. Now again, I observe these RTK observations with 2011 as my designation, but I was really using the 96 adjustment. But I wanted to bring in an Opus solution and a data sheet that's in 2011, so what we see people do is they switch their coordinate system to 2011 thinking that there's not going to be any error, but look what happens when we do this, and we know why, because the local value is holding true and the global value is now incorrect. And now I see I see my 3.5 feet difference in XY and elevation of just over 3 feet. And I can verify this again by looking at the point properties of this point, Apollo, and you'll notice now in this case the local and global values are different, and the local value matches my data sheet. So the Trimble software is handling it properly. However, our workflow maybe wasn't ideal in this particular case. Obviously it wasn't ideal. Oops. What I'm going to do now is also bring in the Opus solution. So there's the XML file I got back from this position, Opus solution. Oh, this project already had that Opus solution in. So let's go ahead and modify this a little bit. Let's see if it'll let me cheat this. Okay, so let's go ahead and zoom in on that. So obviously I had done this once before to verify that this is a problem. So we're inverse between the NGS Data Sheet and the Opus solution. And you'll see it's much closer. So again, it's handling this properly. The point details are correct. I've got two different positions, a local position and a global position. So this is where it comes into play that I should be setting up my project properly and also editing the correct position, local, not global, for 2011. So those are a couple of examples there on real data. So let's look at that for just a moment. So what we did is we wanted to field verify this too, right? We can always just type in some numbers and make it change, but we want to make sure that we field verify this as well. So what we did is we went out and shot 2 NGS monuments. They were collected with different job scenarios. 2 different job scenarios were using a field base, and since we still have a lot of people using VRS, or shouldn't say still, we have a lot of people using VRS, we collected it also with VRS. So it ended up with 4 jobs. Each scenario used 2011 in CONUS, the 2 different datum choices, or I should say coordinate system group choices. However, the base value was always set at the CONUS 96 adjustment because that's very typical. people will do that. So the base was set up at a 96 position, and we collected all this data. We also did one other job, and we collected the information using the 2011 mount point for the Minnesota County VRS, County Coordinate System. So we used NAD83 2011 as our datum choice, and we chose that mount point, and you also see what happens there. And then lastly, we just did an Opus solution just to field verify as well. So here's point Apollo. This is one of the NGS points that we selected. Pretty open. I just wanted to get a picture of it so you can see it was open. It's a Class C order horizontal control monument, second order vertical control monument. And the other point was called Hennen. It's also a C order horizontal control monument and a second order vertical control monument. And you can also see that it's pretty open where this location is at as well. You can see that we used a stable bipod, I guess, setup for our RTK observations. Point Apollo is the only point that we did an Opus solution on. We collected that for about 2.5 hours, and we used a standard tripod tribrac setup for that. So these were the scenarios. Let's take a look at the results. That's always the fun part, to make sure that we are on the right track here. All right. So you can see we've got the 6 examples, the 4 positions, the county one, and the Opus solution. So example 1, that would be these column 2 and 3, because we have 2 points. That was a state plane NAD83 2011 designation using Geoid 12A and VRS as our solution. Again, coming off of a 96 point using 2011, checking into 2011 data. Notice the differences that we saw. A 2D difference of 3.6 feet, 3D of 4.79 feet. So as of note, the results are substantially different from the published values because the data collector is performing that 7-parameter transformation for North American datum of 2011 on the base position. Okay, so that makes a huge error. That was transformed from the original base position, which is NAD83 CONUS 96 adjustment. However, if we check into 2011 control, this is 2011 control. You saw the data sheet here. This is 2011 control, right? From 96 adjustment base using NAD83 CONUS, we check in pretty well. I mean, not right on, but pretty well. So again, based on what we've talked about and what we field verified, we've noticed the results are close to the published values because no transformation is being performed. The errors are the actual differences between the CONUS 96 and North American 2011 datum, and these errors will increase from the base point as we increase in distance from that base point. Example 3. So here's our example 3. This is column 6 and 7, again for 2 points, using 2011 Geoid 12A, but this time we used a radio, a base radio, rather than VRS. This setup we used VRS. So in that example, the results are very similar to the first example, except that our errors are more localized because we're using a local base within a mile or 2 of our base station. Example 4. This time we designated the coordinate system to be NAD83 CONUS. We set up a base radio, and we verified that the results are going to be very similar to example 2, which was done with VRS. That was the only difference, except the error is a little bit more localized because of a base station. Example 5, which is column 10 and 12, or excuse me, 10 and 11, sorry, for the 2 points. Those results are based on the Minnesota County Coordinate System. And when I select the correct datum and projection, like I did in this case, and I select the CMRX 2011 mount point, I'm going to be very close to the actual results. So you notice that I'm very close, 500ths and 900ths, to the actual results because I am using the proper combination. I'm using a 2011 base position, and I'm using the correct designation in the field. The correct designation in the field. And then lastly, verifying it with Opus, which you guys just saw graphically in TBC, to confirm that selecting the correct designation gives me the correct results. And obviously this combination is going to produce the least amount of error. And this data is available for anyone. Again, all base points were in NAD83 CONUS except for 10 and 11, because those were measured using VRS, using the correct mount point and the correct coordinate system designation. And then I also noted here, if you get this information, you want it, you can even go so far as to compare the 96 coordinate values for this point Henan. I don't have the 96 values for Apollo, but I do have them for Henan, to see what should be correct and what is wrong here. Okay. So with that in mind, what we did lastly is we put together this, I guess I'd call it a state, plane, county datum chart. So basically just 3 columns here. What coordinate system selection do I choose? What field or office workflow do I use? And what's going to happen? I think that's pretty self-explanatory relative to what we talked about. So as a review here, when I choose state plane with NAD83 and the CONUS starting position, I check into other NAD83 CONUS positions in the field. That's what I should be doing. If I'm checking in or using, say, an Opus solution, or I'm checking into points that are North American 2011 positions, I'm going to see a slight error. Not huge, but slight. Second scenario. State plane with NAD83 2011 starting position, and that's my designation for the coordinate system within my software. Then my field and office workflow should be checking into other NAD83 2011 positions, and if I do so, I'm not going to see any transformation errors here. Third scenario, if I use state plane with NAD83 2011 designation and Opus, I need to make sure I edit the grid or local position in Trimble Business Center, and I check into other 2011 positions or use the NGS data sheets relative to that adjustment. And if I use state plane NAD83 CONUS and I select and use an Opus solution, it is recommended that you change the datum to TBC to 2011 first, then edit your grid or local position, and make sure that you do that after you change the datum. If you cannot change the datum to 2011 for whatever reason, expect slight errors, just like we see at the top column here, or I should say top row. And then lastly, when I'm using Minnesota County coordinates and I intend to use the NAD83 adjustment, make sure that you're selecting that mount point when you go out in the field, because that adjustment is being handled on the server. You don't have to do anything in the field to select it. That's being done on the server, so nothing needs to be done in the field to adjust for the county coordinate system. So to summarize today's session, we discussed NAD83 2011 and the Trimble software, and some of the workflows and what's happening. And that brings us to the point about global and local coordinates, how important that is. That becomes very important when using the NAD83 2011 designation. Make sure that you're editing your local values and not your global values. I hope you can take that away from today's session. We discussed Geoid Model interpolation. So what happens with the newer versions of Trimble software, whether it be Trimble Business Center or Trimble Access and Geoid Model interpolation, and what file exists with what. We also built a chart there for you. And then we talked about tools for using NGS and Opus solutions, the data sheets and the Opus solutions, using the import routine, saving the NGS data sheet files as HTMLs, making sure that you choose to have NGS return back the Opus XML file so that you can import those files directly into Trimble Business Center. And as you saw, they are brought in properly, and they edit the local position as we noted. Just going to put a plug in for our upcoming webinars next week. Friday we have a Trimble Vision webinar on using photogrammetry with the Trimble optical equipment and data collectors. And then July 19th we have scheduled for narrow-banded radios. Everybody should be narrow-banded now to 12.5 kilohertz. And there are some recommendations on how to operate those radios, what baud rates to have, what power output settings to have, and things like that, how you should operate your radios when using 12.5 kilohertz narrow-banded. You can register for those classes or those free webinars at our website. Here's a little bit of contact info for our different offices, so if you do have some questions, certainly give us a call. I'll put my email up here at the end if you want copies of some of the procedure sheets. You can do that. Remember that this session is being recorded. We are going to make this available for download on our blog, and we will make sure and let people know when that's available for download so that you can do the playback and you can get some of this material. If you do want some of the background information, you can certainly email me, and I will send that to you, and you can review it from there. With that, what we'll do is we'll we've got about 8 minutes. We'll take a few questions, and hopefully the guys have queued up a few for us.
Hey, Steve.
And go from there. Yeah, go ahead, Mel.
Hey, one of the questions that seems to be most popular coming in right now, and I think we should clarify, is when we use the term today of NAD83 CONUS, some questions are coming in saying, well, NGS never published anything that's called NAD83 CONUS.
Right. Mm-hmm.
And you're correct. We're you know, when this person's probably explaining, like, if you looked at a data sheet, it would maybe say NAD83 and an epic date of 1991-35. I want to just make sure everybody walks away. We're not here to explain what NGS is doing per se. We're trying to show you what our software
right
means by using NAD83 CONUS. And Brian and Steve, you can chime in here, but what we were trying to say is that this NAD83 CONUS selection is a 0, 0, 0, which means no transformation. We're not referring this to a NAD83 and an epic date like harm.
No, because Trimble doesn't designate that in their software.
Exactly.
So that's, if you look at my screen now, this is Trimble Access, right? We just have two choices. And what I mean by CONUS is that's the datum that it's using when you choose this system. And what I mean by 2011 is that's the datum that it's choosing when you use this system. That's it. We have no other designation.
So hopefully that answers the person's question that's asking about NAD83 CONUS, what we mean within this webinar, and what Trimble means by the use of NAD83 CONUS.
The other question that we've had come in, and Steve, just so you're aware, only the organizers have been able to see the questions as they've come in. So
I see.
I haven't been able to see them, and Mel hasn't been able to see them unless Jay has forwarded them to us.
I made both you organizers, so
okay.
If you go to the view menu on top and hit questions, hopefully you'll be able to see them now.
Okay. Oh, yeah. Okay, cool. And we've apparently gotten slammed with a lot of questions, which we anticipated, and we'll address those in an FAQ to be published at the time that we publish this webinar. One of the big questions, though, that we've got is what's the difference between 12 and 12A? And the difference is that 12A is a fix to 12 for the coastal states such as Texas, Louisiana, and Mississippi, where the NGS used apparently some incorrect data in generating that Geoid model. As far as our particular distribution footprint, Colorado, Dakotas, Montana, Wyoming, Minnesota, there's essentially no difference between 12 and 12A. 12A is the current one. You can't get 12 from the NGS website anymore, so when we refer to 12A, it's synonymous with 12, at least in our footprint, but 12A is current, so that's what we refer to. You can get 12A from the NGS website, and you can also get it from Trimble.com.
Yeah, one of the other points that Bill made here that's a good point is making sure that we use some acronyms here that we should probably define, TBC and Opus, and we kind of throw them out there loosely, and I apologize for that. TBC is the newest version of software that has replaced Trimble Geomatics Office over the years. TBC stands for Trimble Business Center, and that is the Office software that we use to process our information in the Office. So TBC would stand for Trimble Business Center, and Opus would be the online positioning user service that NGS uses. So Opus stands for Online Positioning User Service. That's a free service that NGS provides to send your raw data files from your GPS equipment from the field to their service to provide very, very accurate positioning back on a single position. So Opus Online Positioning Service, and TBC being Trimble Business Center.
On that subject, Steve, there were some questions on how do I get access to Trimble Business Center version 3. It's available on our blog site at www.fpisurvey.com.
Yeah, I'll bring that up here and show. Yep.
You can even take it for a test spin. It is a demoable version.
Yes. Yep. And then one person just asked to recap that Minnesota County stuff. So here's what Mel's talking about. You can go to the Trimble links here, and you can go to say Trimble Business Center as an example, and this is where you can get version 3.01. Note, very important, 3.01 is a 64-bit install, so you need to know what Windows 7 OS you have. 2.91 is a 32-bit install. Don't mix and match these. Make sure you select the correct one, and Jay can make some other comments if he feels needed, but I know that's very important. 3.01 only supports 64-bit. One of the other questions here that I just wanted to go back to is this recap here. Correct. When you're using county coordinate systems, one of the questions was to recap the distances should be set to grid and the sea level is unchecked. That is correct. That's done in Trimble Access here when you when you set up your project or you look at your project properties under COGO settings. Depending on what version of Access you have, this is an emulator, so it shows a little bit more. It's probably on the second page, but you go to COGO settings, and distances are grid. Sea level correction is turned off when using county coordinates. That is correct. So one of the questions is, working in North Dakota, should I use NAD83 2011? Again, we want you to note, based on these recommendations, it really depends on the information that you have. I would say traditionally, yes, if you use an Opus, because they do have an Opus requirement depending on the work that you're doing. Then you would want to start your project with this NAD83 2011. Check into 2011, and then you're not going to see any transformation or datum errors, so that would be correct. Just going through a couple of these, some of these are duplicates that we've already answered. So is this to say that NAD83 CONUS should never be used with Geoid 12A? No, I wouldn't say that. It's just a recommendation that based on how the adjustments were done, that we would recommend using 12A with 2011 and not with CONUS. But you can certainly use it. It's not going to provide Don't think that you just use 12A and that's going to provide you a better vertical answer when using NAD83 and 96 adjustment. So the webinar is time is up. What we're going to do is there's other questions here that we're going to put in an FAQ, and everybody who is registered for today's session will get a copy of that in an email here, I would say within the week, and so that you can see everybody's question and you can see everybody's answer. Unless Brian or Mel or Jay have something that they had pulled up that they thought was very, very pertinent, we're up against the time clock. So I will just defer to them to see if there's anything else. Otherwise, we'll shut down today's webinar. I do want to sincerely thank everybody for attending. Do you have anything else, guys?
No, thanks, Steve. And I would apologize that we couldn't get to everyone's questions, but we'd be here the rest of the day probably to try and answer all of those. So, and there's some that we probably need to research a little bit, so we don't want to misspeak and make sure we get you the correct answer. So, it's a complicated topic, as you're all aware, and we want to be as accurate as possible as it relates to your use in the field and the Trimble software. So I'd like to offer my thanks to everyone who attended, and that's all I've got, Steve.
Very good. Well, thanks everyone. This ends today's webinar on Datums, NAD83, and Geoid models. We hope you can attend a future session of Frontier. Thank you.